early. Okay. So question 1: when given a sample, or when given a sample, what is the formula for the point estimate for a population proportion? So if you don't know the natural population proportion and you're not comparing anything, p hat is your point estimate, and you find that by taking your collected data for whatever you're looking for over the total sample size.
X over n.
Yeah.
All right.
And you only use that, or actually no. In question 2, you only use p hat when you don't know the proportion.
Yeah.
Like when you don't know the normal proportion, you're trying to figure it out.
So yeah, 2 is giving you the one proportion confidence intervals.
Right.
And it's p hat plus or minus z times p times, or the times the square root of p times 1 minus p over square root of n.
Yeah, and that z is based off of whatever confidence interval you want to use. So that z is either 1.645, 1.98, or
1.96.
1.96 or 2.
I thought it was 1.998.
Yeah, what's the one for when you're 99% confidence interval?
I thought it was 1.998.
The third one?
Yeah.
No, it's 2.558 or 57.
2.57 sounds good.
Let me look. Yeah, so I see 1.96. That's for 95%.
Hey, Daniela.
Hi.
Hey.
Hi. I'm sorry.
That's okay.
Okay.
So we just answered question 1.
Okay.
And we're talking about 2 right now. So Daniela, what is the z-score for a 99% confidence interval?
99?
Yeah, if you want 99% confidence, what z do you use?
I think it's 2.576.
Okay, cool.
Okay.
And then, do you want to answer question 3?
Yeah. What is the condition required to build the one proportion confidence interval above? I think it's the same requirements that the last time, right? That I'm going to show you. These ones, like n
times p.
Is greater than 10, and the other one.
Cool.
Yes.
Okay, if no prior estimate for the population proportion p is available, what is the sample size formula to get the needed sample based on desired margin of error? Explain what each variable stands for. So the formula is n equals the z-score for what sample size you want over 2 times the margin of error that you want, and all of that squared.
She is agree.
Yeah, she's okay.
Hi.
Okay, cool. All right, Andrew, want to do 5?
Yeah. What's the test statistic for a hypothesis test regarding the population proportion? It's the same as number 3. It's NP is greater than or equal to 10, and N times 1 minus P is greater than or equal to 10. No,
that's for 6.
Z equals P hat minus P over square root P times 1 minus P over square root of N.
And so that z that you get, that's what you use in the probability applet? Okay. Yeah, that makes sense.
The next one is, what are the conditions that need to be satisfied? Bueno, is what Andrew said. Is the same as question 3.
Yeah. Okay. And then, okay, so in an October 2008 poll, 684, so that's going to be our X. 1006 is our N, so 684 equals X. 1006 equals N. Randomly selected college students reported that they had been involved in an automobile accident within the last 5 years. Find the proportion of those surveyed who have been in an automobile accident. So P hat.
That's crazy.
Yeah, that is crazy. P hat equals 684 over 1006.
Is 0.6899.
Yep, so 68%. 0.68. Oh, that's what I did wrong. Okay. 684 divided by 1006, not 1004. 6799. Okay. Check the requirements in constructing a confidence interval for this data. So 1006 times 0.6799
is equal
greater
to
than 10.
It's greater than, yeah.
Much greater than 10. And then 1 minus 0.6799 times 1006 is also much greater than 10.
Yep.
You are killing my thumb, little girl.
Determine the margin of error.
That for a 95% confidence?
Yeah.
So we're going to use the z-score of 1.96.
Yes.
Times, shoot, I forget.
The root square, how do you say it?
Oh yeah, the square root.
The square root.
Yeah. Times the square root of p, which is 0.68. Times 1 minus 0.68.
Yeah, divided.
All over the sample size. Okay. Is it? And then you do the sample size plus or minus that.
No, I think
not the sample size. P hat.
No, I think that you don't need to do that because it's only the margin of error.
Oh, you're right. Not the confidence interval. Yeah, you're right.
So it's z times p hat times 1 minus p over n, and it's the square root of the. I'm going to get a calculator.
Smart.
I get 0.0288.
Well, that's good because that's what the answer key has.
Hey, I got that too.
1.96 times square root.
Baby girl, you're killing my finger.
6799 times 1 minus 0.6799.
I think you're going to get a 2 soon.
1006. Great, I got 0.0288282526.
Yay!
Yeah.
Okay, construct and interpret the 95% confidence interval for the proportion of those who have been involved in an automobile accident in the last 5 years. So
you go p hat plus and minus the margin of error.
Shouldn't it be? Oh, I guess that's right. You're right. So 0.68 minus that answer.
I put that in the
0.651 is the lower bound.
what? Which answer?
0.651 is the lower side.
0.68 plus 0.0288. 0.70. 0.701.
Yeah.
Yeah.
0.708
Yeah.
is what it's supposed to be. Okay. So then, do you want to do E, Daniela?
Yeah. How many college students should you survey if you want a 95% confidence interval and 0.015? So I get 4,269.
And how did you do that?
I use the formula about n when you don't have like n equals c divided by 2 times the margin of error and the square of that.
Right. Okay. And what did you say your answer was?
The answer is 4,000.
4268? Cool.
Yeah. Well, it's 8.44, but you need to
round.
So it's 69.
Yep. Perfect.
Yeah. Okay.
Okay. So then for question number 8, now you are interested in testing the claim that over 60% of all students have been in a car accident within the last 5 years. Use the same information as above and use a level of significance of A equals 0.05. So state the null and alternative hypothesis. The null is that the true proportion is 60%.
Yeah.
Yeah.
And then the test statistic we would do, shoot, I always forget that. I'm going to look at the formula.
It's the value minus p, right? Divided by the standard deviation.
Oh, right. You're right. So it's what we got, right? Which was 0.68. Minus 0.6.
Yeah.
All over the square root of
0.6.
0.68. Oh no, 0.6. You're right. 0.6 because now we're using the original p.
Yeah.
Because
Times
we're testing it against something. Times 1 minus 0.6 all over 1006.
Yeah. Or is it the square root of 1006?
Yeah, and all of that bottom part is squared. So 0.6 times 1 minus 0.6 divided by 1006. Answer. Square root of the answer. And then 0.68 minus 0.6 divided by the answer. What did you guys get?
I get 0.5171.
So I got, I was like a 10 off because I got 5.179. So I did something wrong.
I think I am.
You got 5.179?
Yeah.
Well, that's
not
really
right.
Close. The answer key has 5.174.
Okay, so let me try again. So we know that the answer, well, I'm going to use the full 0.6799 because that's what I see on the answer key. So 0.6 times 1 minus 0.6 divided by 1006. And you take the square root of that. And then you say hey, don't jump off my lap. 0.6799 minus 0.6 divided by the answer. 5.179 or 1729. What?
I got 5.1729, but theirs says 5.174.
Yeah, and I'm doing those numbers.
I think they just rounded it wrong, or they typed it in wrong, because like they're missing a bracket and they're missing.
Yeah, it's got to be 5.1729.
Or 5.173.
Yeah.
Yeah. I get
Cool.
0. Yeah.
So the probability is 0. Do you see what on the probability applet picture?
The z-score is like 5 something.
Yeah, that's crazy. So
it's not even a real number.
So the claim is true.
Yeah, we reject. We have enough evidence.
Yeah, get out of here, null hypothesis. Cool.
Yeah.
And then we answered A with that too.
Yeah. So
Cool
let's
beans.
open that quiz.
Is there a train?
No, it's a car.
Ah.
I think.
That was a car. That's a crazy car.
Hey guys, 1 and 2 are true.
Oh, awesome.
Awesome. Wow.
Hey, Daniela, did you get the email that we sent earlier?
Yeah.
Okay. What do you think about it?
I think it's good.
Is it que bueno?
Cool.
Sí, pienso que es bueno.
Entonces, let's do it.
Yes.
The symbol for the true population proportion, P.
Right, not P hat and not. Hey, what's the first one?
It's Pienye.
Pienye.
Yeah. So.
The requirements for constructing a confidence interval are satisfied. So.
Yeah.
It's.
N times P.
N times P
is equal to 10, greater than or equal to 10.
Oh, wow.
Yeah.
Yeah, and then N times 1 minus P is still over 10. True.
Yeah.
It's P, right? Not P hat?
Well, regardless,
P hat.
If it is, well, is that for, that's if we don't know P.
That's one proportion confidence interval.
Right? That's if we don't know what regular P is.
What? We are in 6?
We are
4.
4.
4. So.
Yeah. If you know P, I think you have to use P.
Yeah, if you know P, you use P.
Yeah, so NP is 25. 20. No.
25.
What?
It is 25. And the NP is 25, and then 1 minus P times N is 75.
Yeah. Okay.
So we're good.
It's true, both, right?
Mm-hmm.
Yeah, I think so. Hey,
and the hypothesis test, they're satisfied.
Right. Okay, study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of the 45 of the 45 of the defendants were found guilty. So the guilty would be 45 over 60.
0.75.
Right.
Right.
Bien.
Just.
Okay. Create a 95% confidence interval for the true proportion of first-degree murder trials in this state. they're in this state there where they're the what?
Create a 95% confidence interval for the true proportion of first-degree murder trials in this state. There, the verdict is guilty. It's supposed to be this state where the verdict.
Okay, where the verdict is guilty. Okay, so 95% confidence. So we're going to use Z times the square root of P hat times 1 minus P hat over N. And our Z is going to be 1.96.
1.96 times the square root of, and P hat is 0.75?
Yeah.
Times 1 minus 0.75 all over
60. I got 0.1095.
I will get 0.109. Okay.
0.1095.
What do we do though? Because we should round 9.
1.11.
Okay.
Round to 3.
0.10. Oh, I see. 0.110, but 0.11.
Just put the 0 on there just in case.
Okay.
Lower bound. Z 1.96 minus.
We can use Excel. Oh, wait. It's okay.
I think we could do it already. We could go point.
You go 1.96.
6.68.
Plus that? Yeah, 1.9. It's
we go
1.96 plus that and minus that.
Yeah, 0.75 plus and minus that, right? 0.75 is our P hat.
Yeah.
So 0.75 plus and minus 0.11.
Yeah.
So
minus, lower is 0.64.
Okay, so I'll do plus 0.11 is 0.86. So, but we want the lower bound.
I got lower bound.
What did you say it was?
0.640.
0.64.
I mean, 0.75 minus 0.11 is 0.64.
Yeah.
What is the lower bound?
0.64.
Okay.
And the upper is 0.86.
If you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval?
It will decrease. Because you'll be more confident.
Yeah.
By taking
with a larger sample size, you have a smaller margin of error.
Yeah.
Or your confidence interval.
To conduct a hypothesis test. Are you so tired? Is that why you keep rubbing your eyes?
Well, she has a concussion.
Yeah.
We learned that's a sign of concussion.
So you're rubbing your eyes?
Mm-hmm.
Okay, to conduct a hypothesis test for one proportion, 2 requirements must be met. Suppose P equals 1/2. What is the smallest N can be both?
20.
Nice. Well, hold on.
NP is greater than or equal to 10, and N times 1 minus P is greater than or equal to 10.
You're right, because 20 times 0.5 is still 10.
That was a question last time, too.
100.
100?
For 12.
Is it?
N times P, something times 1 over 10.
Uh-huh. That's the smallest. Yep, 100. And then 100 times 0.9 is 90, so we're good.
Uh-huh. Okay, I'll put you down. You're rubbing your eyes so
So
hard.
really, you just have to worry about satisfying the first one. If you can satisfy NP is greater than or equal to 10, then you're good.
Right.
So
P equals 38 over 80.
we are in 12.
We're 12 was
That's 100.
Yeah,
right?
So 13.
Okay.
Yeah, I think they are satisfied.
P
38
equals
over 80.
P equals 0.475. So NP
Right. Times
80 times 0.475 equals 38. So we're good with there. And then 80 times 1 minus 0.475
Yep, we're good again.
equals 43.44.
True.
Yes.
Yes. So
What is P hat?
0.4.
Find the test statistic.
So that's going to be the
P hat minus P over square root P times 1 minus P over N.
Okay, and we're using their P as 0.6.
Yes.
Okay, so we have 0.475 minus 0.6 all over.
I thought it was a stew.
I know. Well, the recipe didn't give you enough liquid.
Hey, don't pull on that. Hey,
You're good.
hey, let go.
I was just like doing it.
This is telling Maddie to let go.
So we ran out of beef broth, and then we
Okay,
also had to
so
use broth.
that over the square root of
I needed 2 cups when I had like a cup and a half.
0.6 times 1 minus 0.6 all over 80.
Chicken broth?
Cup of it.
Yeah. Negative 2.28.
Negative 2.28. Thanks. And the p-value for this test?
Well, negative 2.282. That's what they tell you to go to.
Negative 2.282. That's 15.
Yeah.
Did any of you guys put this in the Excel thing?
I
didn't do
doing that. So X, what is X? I can give you
X is 38.
38. And N is what?
N is 60? Hold on, no, 80. N's 80.
What are
Confidence level
is this the one sample? No, that's a z-test.
So the null hypothesis is 0.60 and the other one is greater than, right?
The alternative is P is less than 0.6.
Always. So the p-value is 0.011.
0.01. Yeah, that's what I got on the applet.
0.01?
0.011.
Okay. And 17? So
we reject it.
Our confidence is 0.05, but it's less than.
Yeah, so we reject it.
Yeah.
We have enough evidence to reject it.
Yes.
So we don't fail.
Andrew, you're being confusing.
Which of the following best summarizes the conclusion of this test? There is sufficient evidence to conclude that the water quality in the area is not decreased.
I'm going to say it has decreased. Hold on.
Fine, it is the last one.
Well, we didn't ever read the instructions for the whole thing. So for the water quality study.
Yeah, but we're looking for less than. So we rejected the null.
Right, but what does
it's less than 0.6?
right? But what does 0.6 mean?
It means that 60% of the macro and vertebrate water quality indicators have historically been associated with good health.
Right.
The researchers suspect the water quality in the area has decreased.
Right.
So it has decreased.
Yeah.
Has decreased sufficient evidence, right?
There is sufficient, correct. The last
I submitted.
Did you get it right?
19 out of 19.
Woohoo!
Why is it 19 when there's only 18 questions?
What?
What?
There's 18 questions and it's 19 out of 19.
Yeah, that's weird.
Maybe one of them was worth 2 points.
Or some of them are worth like.
There's 1/2 point for 8 and 1/2 point for 9.
Whatever. Cool.
Yeah, it doesn't make any sense to me.
Okay, so Daniela, I will.
2 points for the first 2.
I'll submit our research paper to our professor.
Yeah.
And then the next Tuesday we can talk about what we're all gonna do.
Okay.
Cool.
So I don't need to go to Walmart this week.
No, I don't think so.
No. Okay.
I mean, if you want to, you can.
No. Yeah. Thank you.
But you don't have to go if you don't want to.
Okay.
But if you want to, you can.
Okay. Thank you.
But you don't have to. I don't think you have to go this week.
Cool. All right, everybody. I'm gonna stop recording.